All right, so what we're going to do in this lesson is just a very simple progression from what we've been doing with these sequences to start performing some operations on these sequences. All right, so it begins with us just using a sequence that we should be pretty familiar with, just a basic arithmetic sequence here, and we're going to consider this sequence A of n. And we're asked to find the first three terms and then add them all together. So let's do that. I'm going to do that pretty quickly because it's something that we're pretty familiar with here. So to find a of 1, this is nice because it's explicit. All I need to do is plug in a 1 and I get 4. All right, that's pretty nice. A of 2 is just 3 times 2 plus 1, which is 7. And the third term is 10. All right, pretty quick. We're just evaluating this explicit definition we've been given. Now we're told to add them together. So I'm going to take 4, 7, 10, and add them, and I'll get 21. So that's not too difficult, but again, like we were seeing in previous lessons, we can envision a world where maybe more is asked of us here. Maybe they don't say add the first 3 terms. Maybe they say add the first 80. Or maybe they say add terms 22 through 67, right? So this is going to start to become a problem if it's more than 3 or 4 terms or something we can do in a reasonable amount of time. So what we have is we've got a function that can actually do this for us. And once we get into class, we'll start doing this with the calculator. But that function is called a summation. And the symbol that's used for a summation is called, it's a Greek letter, and it's called sigma. And it looks like this. It's almost like a big letter E. All right, so there are some components to this Greek letter sigma, or this summation, that we need to make sure that we're familiar with. At the bottom of this sigma, we're going to have n equals or x equals, or whatever our variable is. It's going to say n equals something. And that something, that in this case a, is representing the number of the first term in our sum. All right, so if I'm starting with term 1, like I did here, then a is 1. If I'm starting with term 62, then a is 62. All right, there's another component of this. At the top of the summation, you're going to see another number. In this case, we'll just call that b. But that number represents where we're going to end, or the number of the final term in the sum. So in this case, we would have had b equal 3, right? Because we're saying to add terms 1 through 3. So a would have been 1, and b would have been 3, and that would be telling the function to add the first through the third terms. The last component here is we have to tell the function, the summation function, what function to use. So there are a couple ways to write it, but here I'm just going to say f of n to represent whatever function we are using. So in this case, f of n would have actually been a of n, this here. All right, so there are a couple ways that we could have written this in sigma notation. We could have said here that we want to add together, that's what using sigma means. I want to add together terms 1 through 3 of my a of n sequence. And if I plug this into the calculator correctly, and I could do some things in the calculator to figure out how to tell the calculator what a of n equals, but I would get 21, and we'll, in class, prove that we get the same answer here. And it's going to become important to use that sigma in summation notation because we're going to have some sequences that we're going to have to add together a lot of terms, and it would just take too long to do it by hand. Okay, so let's calculate the following summations. We'll do these by hand, and then in class we'll check them with the calculator. But we need to make sure we understand what these mean, these summations. So what this summation is saying is that my function is 3 times I, and we don't want to think of I here as the imaginary unit. In this case, it looks like I is being used as a variable, and very often that is the case with sigma in summation notation. They will use I as the variable. You know that it's being used as a variable because at the bottom of the sigma, it says that I equals 2 is your starting point. So the first number that we're going to plug into this function is 2. That's the second term in this sequence. Remember, I don't even care what the first term in the sequence is. I'm just told to add terms 2 through 5. So I'm going to add term 2 and term 3 and term 4 and term 5. So that's what that says to do. This sigma is telling me, take the second term, the third, the fourth, and the fifth terms, and add them all together. And we can do that by hand here. 3 times 2 is 6, plus 9, plus 12, plus 15. And if we add all those together, it's not actually too bad. It's just 42. All right, so when we get to class, we'll check that with a calculator. But a question that you might be asking is, why am I only plugging in 2 and 3? Why not 2.1? Why not 2.2? Why not 2.3, 2.4, 2.5? Why aren't we doing all that? Well, that goes back to in the first lesson when we talked about n. When n represents the number of the term, or in this case, it's I that's representing the number of the term. Remember that that variable exists in all of this, in the set of all integers. So in this case, I would have to be in the set of all integers. It would not be the case that I could be 0.1 or pi or something like that, right? If we're saying that I is part of a sequence and we're going to use a summation, which we use for these sequences, then we're saying that the numbers we're plugging in are only the integer values between 2 and 5. So it's important to not get confused and think that you have to add all the decimals in between. All right, the next one here says that our function is 1 to the k power. It looks like k is the variable that's being used here. And they're telling us to start with the negative second term and end with the second term. So that means that the first number I'm going to plug into my function is -2. And then I have to add to that 1 to the negative first. And I have to add to that 1 to the 0. Don't forget that 0 is part of this here. Plus 1 to the first, plus 1 to the second. So we're adding 5 terms together here. And again, in this case, k would have to be integers. So now we have to figure out what these are. And although it looks a little scary, it's really not too bad, because remember, negative exponents just mean to flip this fraction. And 1 squared is 1, 1 divided by 1 is 1. So it turns out that 1 to the -2 is 1. 1 to the -1 is also 1. Anything to the 0 power is 1. 1 to the first is 1, and 1 to the second is 1. So this sum is actually 5. It looks intimidating, but it's really not too bad. And again, we'll check this when we get to class tomorrow as well. All right, so what I want you guys to do before we get to class tomorrow, because these bottom 2 examples are asking us to express these sums using sigma notation, I'm going to say hold off on that part of it for now. We will do that in class, but you don't need to do that right now. The first thing I need you to do on your own is what we would have to do anyway, is define these explicitly. So first, define each of these explicitly, because that's going to be an important thing for us. Before we can even use summation notation, we're going to have those 2 things be defined explicitly. All right, so do that before you come to class on Monday, and on Monday we will go over how to use sigma notation in the calculator to make our work go a little quicker. All right, have a good weekend. See you guys on Monday.